So earlier we learned that whenever we use loopback to loopback neighborship, mostly we use that in an IBGP situation where we have redundant paths. We do that to match the neighbor's neighbor statement. For B, C is the neighbor. For that neighbor, there is a neighbor statement with an IP address 2222. So B should send with the source address 2222. That's why we say whenever you speak to 3.3.3.3, use the loopback 0 interface IP address as the source address. So we need to do it on either side because on both sides we use loopback interface. Now, next. There may be a situation, very rare scenario situation, where you have a dual homing between two autonomous systems. You got not multi-homing, this is dual homing. Connecting two connections. We have two active connections to ISP or two active connections to your neighbor autonomous system. Even this situation we need to use loopback, because loopback, even if one of the active link goes down, you will be able to still ping between 2222 and 1111. What are the things that we need to consider? First thing, we need to make sure these two are pinging so that TCP/IP three-way handshake will happen. So I write a static route from A to reach 1.1.1.1 via both the physical paths, you see, 18 and 34. Likewise, on router B, we write static route to reach 2.2.2.2, 17 and 33. That's the very first basic requirement. First of all, you need to have reachability. Next, do you remember ebgp neighbors need to be directly connected? To make sure the ebgp neighbors are directly connected, BGP has got the default time to leave as 1 to ensure that neighbors are directly connected. TTL, time to leave, in layer 3, that helps in lot of ways in BGP, in OSPF, in every place. Time to leave is a default loop prevention mechanism in the layer 3 header. So it's the same time to leave that is used by BGP to control the neighborship. ebgp cannot be more than one hop away. In another word, ebgp neighbors network should be seen as directly connected in the routing table. Should be seen as directly connected. Look at this. If I have two routers with 10.1.1.1, 10.2.2.2, and I got loopback 2.2.2.2, 1.1.1.1. Now, in router 1, when I say neighbor 2.2.2.2, will this two network in R1's routing table directly connected? Will that be shown as directly connected? No way. No way. It is not directly connected. Even though it is connected to the router which is directly connected, even though it is 2222 is connected to the router which is directly connected to you, 2222 is not directly connected. In the routing table, you may be writing a static route to reach 2222. In that, what you will say? It is connected via 10222. So ebgp cannot form neighbor. ebgp very clearly will check whether this address is shown as directly connected in routing table, which is not possible. So to break this expectation of BGP, you need to increment the TTL value greater than 1. Simple. When you put greater than 1, meaning 2, router 1 will now use the route given by you, the static route, to reach 22222 and go out. Is 22222 2 hop away? Is your argument. Though it is in 1 hop away, it is not directly connected. Because it is not directly connected, BGP cannot even send any packet. It won't send any packet, first of all, outside. But when you say to BGP's that rule is broken. What rule? The neighbor address need to be directly connected. The 2 network need to be directly connected. The rule is broken. All that it will do is it will just check whether I got a route. It need not to be directly connected. I got a route. If I got a route, I'm going to use the route. And BGP will use hop count 2, TTL2, as the outgoing hops. Outgoing TTL is going to be 2, and it will send the packet to router 2 using the static route that you have given to reach 22222. It will send to router 2. Please understand this very clearly. ebgp-multihop command is not only to increase the TTL value, which is very importantly to break the rule of ebgp's neighborship. By default, ebgp neighbors need to be directly connected, meaning if the neighbor address is 10.222, this 10 network is seen as directly connected. For that, you no need to increment the TTL value. The routing table will show 10 network, the neighbor's network, as directly connected, physically connected, directly connected. Now, happily BGP will send the packet because it is under the rule. But when you give a loopback interface, as the neighbor address, neighbor's loopback interface address as the neighbor address, routing table is not going to show that as a directly connected. As a result, packet won't go outside. It won't even go and try. Because the rule, default rule, is not satisfied. Directly connected rule is not satisfied. It won't even go out. Even though this 2222 is in one hop away, is it 2 hop away? Router 2? No. Router 3 is 2 hop away. Even though 2222 is in one hop away, we have to say BGP2 so that BGP will know the neighbor is not directly connected. The neighbor, if it is 2 hop away, how it can be directly connected? When router 1 knows that neighbor cannot be directly connected because the TTL is configured as 2, it ignores the rule that neighbor need to be directly connected, seen as directly connected in the routing table, and now tries to send the packet out. That's why we need this command. And you know this command already, and you know why we need to write static route. Let me show you all these things in today's demo. Please focus here. Let us first form neighbor using the directly connected network IP address. Router BGP30. What will be the neighbor address? Can someone say neighbor address?
.5.
Alakadal.
56.56.
56.56.56.5. Remote AS is 20. So this is normal ebgp configuration using directly connected. Next, I'll go to router 5. Router BGP20. Neighbor 56.56.56.6. Remote AS 30. This neighbor will come immediately up, I tell you. This neighbor has got no problem. See, it has come up. The reason, you know why? You are saying neighbor is 56 network. See the routing table? Show IP route 56, 56, 56, 0. It is said directly connected. The word is very important for BGP. Show IP route. See, even here you can see directly connected. But is the 66 network directly connected? Show me where it is directly connected. It says we are. See, it is not directly connected. 66 is not directly connected. Even though it is on the router which is directly connected, routing table don't show it as directly connected. So, one more thing I want to show you. Show IPBGP neighbor. If you see with 56, 56, 56, 6 router, whose router ID is 66, 66, that is dynamically picked, 66, 66. That is the router ID of router 6. So router 5 knows even the router ID of router 6. But this is not the address with which we form neighbor. We form neighbor with the physical interface address. And now if you go down, I'm interested in showing you the TTL. Look at this. The outgoing TTL is 1. Yeah. The outgoing TTL is 1 to make sure the neighbor's network is seen as directly connected. Yep. Now I'm going to change it by removing the neighbor. I remove the neighbor. The physical interface address is no more the neighbor's address. Instead, I write neighbor is 5.5.5.5, remote AS is 20. On router 5 also I say neighbor is 6.6.6.6. We also have an address called 6.6. Remote AS is 30. Now what is the very first thing I need? I need route to reach 6.6.6.6, which I don't have. See, router 5 cannot ping 6.6.6.6 with the source 5.5.5. This ping should happen between loopbacks. The ping should happen, only then TCP can negotiate, right? So let us write a static route. Hold on. Earlier I have a static route for 66. I need to remove that. I don't want route for reaching 66 network. I remove this. Instead I write this. Fine. Likewise on R6 I should have a route to reach 5.5.5.5, which I already have. So if I go back and try pinging this one which I pinged earlier, which was not pinging earlier, now it pings. Okay, you got basic IP reachability to the neighbor address. Happy? No, not happy. BGP is not happy enough. See, I'll show you BGP will not even send a single packet outside. Even though the route is available. Sorry. Even though the route is available, see, you are able to ping, no? Even though you are able to ping, and it's the same address with which you have formed a neighbor. You said my neighbor is 6. Actually, the 6 is reachable. On the remote router, you said neighbor is 6. On the where is the remote? On the remote router, we have said the neighbor is 5. These two addresses are pingable from both the sides. Ping 6.6.6.6 with the source 5. So this is also sorry, I made opposite. Ping 5.5.5 with the source 6.6.6.6. You see the ICMP is going. These are all ICMP. But do we see any TCP packets? Let me filter and show you. TCP, no TCP packets. BGP, no BGP packets. No TCP, no BGP packet. Let me start the Wireshark once again. Yep. You will not see any TCP or BGP packet. Why? It is not because of... that is what I was about to say. It is not because of the update source. See, update source, whether you put or not, the BGP should go and check with router 6. And router 6 will say, okay, sorry, your source address is not matching. I can't form neighbor with you. Something should happen like that. You see, nothing is happening like that. Update source is not the problem here. The problem is the 6 network. Okay, sir. 1 minute. The 6 network is not seen as the connected in routing table, you see. Is it shown as connected? 6 is not shown as connected. It is shown as via this. If it is connected, by this time it would have sent some packet. So, we are going to say to BGP to break the rule. We are going to say to BGP, it's okay, even if it is not directly connected, you can try to reach the neighbor. How we do that? Router BGP 20, and we say neighbor. Whenever you speak to the neighbor 6.6.6.6, ebgp-multihop 2. Same way I have to do it on R5 or 6. See, now you started seeing behind the screen, you see TCP packet started going now. Router BGP 30, neighbor 5.5.5.5, ebgp-multihop 2. Fine. So only after we make the multi-hop 2 command, we make the TTL to be 2, outgoing TTL to be 2, the packet is trying to do something. The TCP is trying to do something. But still you don't see BGP. TCP is going from the physical interface to the neighbor. But the physical interface will not match with the neighbor statement. So for that, what I need to do? Update source. And now you see the BGP packets are going. Now both the side, you will see three-way handshake happening. Let me stop the capture and show you. See, starting from here, you see there is a bracket in the line. There is a line here. It shows the session started there and it ended here. It ended here. So the packet is going from 6.6.6.6. Now this source address is the right source address which matches with the neighbor statement on the neighbor router. The three-way handshake is completed, followed by open message. Open message will send the hold time, router IDs, and so on. You see, open message, hold time, router ID, and so on. And from both the sides, the router ID and the hold time and autonomous systems are shared. Keep alive messages for checking whether we both are connected, and then the acknowledgement. Finish. So the three-way handshake is over. After that, BGP open and confirm happened. That is how you got the neighbor. Show IP BGP summary. You got the neighbor. Neighbor is up for last 1 minute and 27 seconds. Now, if you type this command, show IP BGP summary. Show IP BGP neighbor. Earlier I showed you the TTL was 1, but now the TTL, outgoing TTL, is 2. Only when you make it as TTL value 2, outgoing TTL 2. The rule get broken, and you will start sending, you will see BGP start sending the packet. Otherwise, whatever you do, update source you do, it won't be useful. It won't even send one packet also out. If you don't change this, if you simply say update source loopback 0, that will not work. That also needed, but before that you should first of all break the rule. What rule? ebgp need to be directly connected by putting this command ebgp-multihop to. See, this constraint is not for IBGP, it's only for ebgp. For IBGP, you don't have a command ebgp-multihop command. Please ask me a question. Is it clear so far? If it is clear, say clear, someone. I'll go to the next
one. What about IBGP neighborship? Last one, can you repeat? I mean, can we...
See, only for ebgp, this constraint, this requirement, like need to be directly connected. For IBGP only, for ebgp only, the default outgoing TTL is 1. We are changing into 2. For ebgp, you know what? Sorry, why I'm confusing. Listen, you asked for IBGP, right? Only for ebgp, the outgoing TTL will be 1, and we need to change it into 2 if you are forming neighbor with the loopbacks to loopback. But for IBGP, by default itself, TTL value will be 255. 255. What does that mean? It means the neighbor need not to be directly connected. He can be anywhere in 255 hops. You understand? IBGP neighbors can be anywhere. He need not to be directly connected. So what is how BGP knows it? Because the outgoing TTL will be 255 by default. Kindly respond me. Do you understand? Or should I repeat? For IBGP, the outgoing TTL will be 255. That means neighbor need not to be directly connected. So you no need to use that command, multi-hop command, for IBGP. Yes, Murli, please question me if you don't understand. If you understand, please tell me you understood.
So if we have a loopback inside IBGP, so when we should use update source?
Update source is always needed whenever you use loopback.
Okay.
We are not speaking about update source. We spoke about multi-hop command, ebgp-multihop.
Okay.
This multi-hop command is only for ebgp. There is no need for IBGP to increase the TTL value, because by default the outgoing TTL will be 255. Let me quickly show you that also. Right, as that is booting, I also want to take you back to the Ether Wireshark. Listen, if I open a BGP packet now, what will be the TTL value? Can someone say what will be the TTL value? 2. Where you can see in IP protocol and layer 3, you see TTL is 2. Modified. Even every packet, even this packet will show the same information. TTL is 2. All TCP. Any communication on behalf of BGP and by the BGP will be having TTL of 2. Is it clear? Now, we got IBGP routers ready. Let's get the console quickly. Alright, if you now go to router 5 and say Router BGP 20, you got a neighbor called 2.2.2.2, remote AS is 20, and then you need to say update source. Now you will see neighborship coming up, because on R2 I have already configured, I remember. Yeah, you see, BGP neighbor has come up. BGP neighbor has come. I want to show you that the TTL value of outgoing with neighbor 2222 will be 255. Show IP BGP neighbor. First, let us see which neighbor it shows. Yeah, for 2222. Is it IBGP? Of course it is IBGP. Go down and see. The TTL value will be 255. For IBGP, the TTL value is 255. But for ebgp, I showed you earlier it was 1. Why they have said this? This means that IBGP need not to be directly connected. That is the meaning of TTL value 255. ebgp need to be directly connected. That is the meaning of TTL 1. But because we are forming neighbor between loopback to loopback in ebgp, we have changed the TTL value to 2 hop away. 2 hops away, where it is. Can be anywhere less than 2 hop away. Right? Is this clear so far?
Yes, sir.
Now next is, there's a big argument between me and Murli. What is that? Murli says, Indasare, what is this? You are saying outgoing TTL value as 2. There it is. Outgoing value is 2. But incoming you don't care. Incoming can be 0 also. What does this mean? We are not checking whether the neighbor is really coming from less than 2 hop. If you say 0, if a neighbor is coming from 10th hop also, you will not know. If a neighbor is coming from 255th hop also, you will not know. TTL value will be 0 if someone is sending a packet with 255. When will it become 0? When it jumps 255 hops. Is that right? Yes. When someone is sending packet with 255 TTL value, for every hop it will decrement 1, and when it reaches me, if it is 0, what does that mean? The packet is coming from 255th hop. So here we are saying we don't have any problem even if neighbor is coming from the 100th hop. This is not really secured. We are just focusing on outgoing. My packet will not be valid more than 2 hop away. But that's not a security for you. You are sending packet saying, I want to see my neighbor in 2 hop away, only then I will form neighbor. Fine. What if your neighbor is coming from 100th hop? He is an attacker. Do you have any check for that? No. So if you want to do this in a secured way, what you can do? You can remove this neighbor ebgp-multihop. Instead of saying I will send, instead of saying instead of sending I will send with hop count 2, you can say like this: I'll send with, see, this is the command, different command, TTL security hop 2. What does this mean? I will send with the maximum hop outgoing as maximum, repeating again, My outgoing TTL I do not want to care this time. This time I do not want to care about outgoing. I will expect my neighbor to be 2 hop or less than 2 hop. That's the meaning of this. My incoming, when I receive a packet, the incoming TTL should be 255 or 254, 255 minus 2, meaning 243. If someone is sending packet with 255, if I receive the packet with 254, what does that mean? He is 1 hop away. If I receive the packet with 253, what is the meaning? He is 2 hop away. So when you say TTL security hop 2, let me remove from router 5 also and show you. Router BGP 20, I remove this. Hello, where is the ebgp-multihop command? I remove this. Instead I say, wait, I will also sniff the packet. Start the capture. Earlier we were only focusing on outgoing. That really did not benefit as well. So this time we are focusing on incoming, and outgoing we don't care. We just send it to 255 hops. See, that's what I'm going to see. Right now it is sending to 1 hop. Sorry, 2 hop. 1 hop. Meaning I think I removed the command now. So it is sending to 1 hop now. It is sending to 1 hop now. Now I'm going to say no. First of all, let me clear BGP. I'll break the BGP neighbor. Clear IP BGP start. Now there won't be any packet going. No more TCP, no more BGP, because the rule need to be directly connected is now on. Loopbacks are not directly connected. So this time I'm going to say router BGP 20 neighbor 6.6.6.6 TTL security hop 2. I'll do the same thing on R5, R6. Done. Now you will see packets going with 255 hops out. You see? Let me stop. If you open and see this, see the TTL outgoing is 255 now between ebgp. Why? I don't want to care about outgoing anymore. How many hops my packet goes, that doesn't matter. Is neighbor really connected to me? I want to check. Is he less than 2 hop away? I want to check. Show IP BGP neighbor. If you see now, this is going to focus on only on the incoming. If the neighbor is really less than or equal to 2 hop away, when the external BGP neighbor is really less than or equal to 2 hop away, only then you will have 253 or 254. If it is 252, it won't accept. Earlier, even if it is 0, it was accepting. But now it says he is sending with 255. If it is jumping to router, then he should be 253. If he is jumping one router, it should be 254. I'll accept 253 or 254, but 252, 251 and all I will not accept. This is the minimum. I cannot go minimum less than this. So this is more secure than the previous one. Checking the incoming TTL value is more secure than sending with outgoing TTL. So who will use this one, who will use that one? Most of the security engineers who knows BGP, if they configure, they'll use this one. But generally the enterprises people, they don't know this command. Even in the presentation you did not see this command. You see only ebgp-multihop command. ebgp-multihop focuses on outgoing, TTL security focuses on incoming. Actually, for providing security you have MD5 authentication, but this is an additional security. To prove I am a security engineer, I need to do some extra thing, no? So I can do this one, TTL security. But enterprises guys will say, what man? What do you think about yourself? Funny boy. MD5 authentication is there between these two routers. That provides enough of security. Why you simply talk about this story? That's the argument what the enterprises people will have. Both are right. He says I am giving additional security. Yes. This man says why there is need for additional security when MD5 is already secured. What if I don't have MD5 authentication? Is the security guy's argument. Then enterprises guy says no, you should have you are saying security engineer, what is this? You don't know? First you put MD5 authentication like this. Router BGP 30. Neighbor, whenever you speak to this neighbor 55555, use the password Cisco 123. Now if you see the packet capture, the packet that is coming from 6.6.6.6 need to have some hash values, authentication enabled. Let me go to router 5 and clear. 6.6.6.6. Okay, you see the neighbor is deleted because of bad authentication. Now let us pick one packet and see. Coming from 6. Coming from 6, the keep alive, the TCP protocol should have some authentication in it. See, TCP MD5 signature. This is the MD5 message digest hash value. Whereas the packet coming from 5 don't have this field. Packet coming from 5 don't have that field. Only 6 has got that authentication field. You need to match on either side. So going to router 5, whenever you speak to the neighbor, use the password Cisco 123. Now both the side we have enabled the authentication and we are expecting the neighbor to be up shortly. Clear IP BGP start. Okay, BGP has come up. Fine, the three-way handshake should have got over. Finished. Authentication is clear now. See, the BGP is up. but still it shows no message digits. This is funny actually. Some operating system you need to restart the router to stop this. Not all operators, it's already up. If this is keep on coming, you restart the router, only then it will stop. That is iOS issue, right? So you can see even the neighbor is established. Thanks for joining.